Okay, this is section 2.3, solving polynomial equations. This is day 3 of our polynomial unit. So we start out looking at these two problems, okay? They look very similar to each other. One is an equation, one is not. So this is stuff we did last semester. So factoring the one on the left, that will factor if I can find two numbers that multiply to -12 and add to +4. So those numbers are going to be 6 and 2, with the 2 being negative. Okay? That means I can go straight to factoring this. X plus 6 times x minus 2. That is my complete factorization. Now the problem on the right means to solve it. So factoring is the method I use to solve it. So this is x plus 6 times x minus 2 equals 0. So if you will note, I have two things that are multiplied to give me 0. If two things multiply and the answer is 0, then one of these things has to equal 0. So that's why I do x plus 6 equals 0. That means that x has to equal -6. If x minus 2 equals 0, that means that x has to equal +2. So these are my solutions to this equation. Now you notice if this were x plus 6 times x minus 2 equal 1, okay? I can't solve that with the same method because two things multiply to give me 1. That doesn't translate to one of those things is equal to 1. You know, that could be, one could be 2/3 and one could be 3/2. Those multiply to give me 1. So there's something special about setting it equal to 0, because when things multiply to give you 0, one of those things that you're multiplying by has to be 0. So that is very key in solving any equation. Is setting equal to 0 is a powerful way of solving, because then the factors will help you determine the solution. So here are our steps. Gather all the terms on one side of the equation and a 0 on the other side. Factor completely, and then each of those factors has to be set equal to 0. So this is where we're going to put into place everything we've been doing with the factoring so far in order to solve equations. So let's take a look at the first one we have here. If I look at this, first step I want this equal to 0. So I'm going to write 4x to the 5th minus 40x cubed plus 36x equals 0. It is set equal to 0. Now I want to factor. The first thing you want to try in every factoring, if at all possible, is factor the greatest common factor. So if I can find a greatest common factor, that will simplify this equation. So it looks like I can factor out a 4x. Okay, in the first term, what do I multiply 4x by to get 4x to the 5th? That is x to the 4th. And then minus 10x squared plus 9 equals 0. So now I've got two things multiplied to give me 0. One of those things has to be 0 for this to be true. Then the question becomes, can this be factored further? Okay. Now you need to recognize what that is. That's not a quadratic, but that is quadratic form. We talked about that in the previous lesson. So it's quadratic form, which means I can basically factor that just like I do a quadratic. If I can find two numbers that multiply to give me a 9 and add to give me a -10. So it looks like a -1 and -9 will do that. You multiply those numbers, you get +9. Add those numbers, you get -10. So I can write this as 4x and then x squared minus 1, x squared minus 9 equals 0. Now note the difference there. This was not a quadratic, it was quadratic form. So that middle term was an x squared. That's why this is an x squared and this is an x squared. And you can check, multiply those two things out, and you'll get back that x squared minus 10x plus 9 equals 0. Now you have to set each factor equal to 0. 4x equal to 0. X squared minus 1. Sorry, let me back up before I do that. I want to factor completely, so I got ahead of myself there. 4x. Inside this parentheses, that is the difference of squares. That can be factored. Inside the next parentheses, that is the difference of squares. That can be factored. And I can't remember if I said it previously, but if I did, I was wrong. Now it's completely factored. So I can factor this no further. Now I just set each thing equal to 0. That means that x is equal to 0. X minus 1 equals 0. That means that x equals 1. X plus 1 equals 0. That means that x equals negative 1. Those are 3 of my solutions. And then the other solutions are going to be 3 and negative 3. Okay, so there are 5 solutions to this. Okay, all that came by factoring. But you got to keep in mind, what did we do? We started out, we factored the greatest common factor. That was the first method we had to use. Then we had to use quadratic form. And then we had to use the difference of squares. Okay, I say that factoring was a bag of tricks, and you just have to figure out which tricks work. This one we had to use 3 of those tricks or 3 of those tools to get this guy to factor. Okay, let's move to the next one. Find all real solutions. Okay, now if I look at this, I have to recognize the method that would factor here. It's not greatest common factor, it's not difference of squares, it's not a quadratic, it's not quadratic form. This is the sum of cubes. So it's the sum of 2 perfect cubes. Your teacher said that you need to memorize the formula for factoring this. So a cubed plus b cubed. That is a plus b times a squared minus ab plus b squared. That is how you factor the sum of cubes. The way we remembered this was this sign is the same, this is the opposite, and this is always positive. We have that acronym SOAP. So if I look at this plus sign, this sign is the same, that's opposite, that's always positive. So in factoring this, applying this formula, a, in my case, is going to be 2x, because a cubed is 8x cubed. And b is going to be equal to 3, because b cubed is 27. So I've got a cubed plus b cubed. So in order to factor this, what is a plus b? That's 2x plus 3. Times, and then you square that a term, that's 4x squared. ab is 6x, and b squared is 9. So all of this is equal to 0. Now you want to set each factor equal to 0 and solve. So 2x plus 3 equals 0. That means that 2x equal negative 3, x equal negative 3 halves. Okay, that is one of my solutions. Now the next thing I have to do, I have to figure out this quadratic that I have here. Can this be factored? Okay. Well, if it factors, there are 2 numbers that multiply to 36 and add to negative 6. The factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. There is no way to add or subtract any of these numbers and get a 6 or negative 6. Okay, this one is either going to be 35 or 37. That's 16 or 20. That's 9 or 15. This is 5 or 13. That is 0 or 12. So I cannot factor this. Okay, so if I'm trying to solve this, 4x squared minus 6x plus 9 equals 0. There's another way we learn to solve something that looks like this. And that was our lovely quadratic formula. So x is going to be equal to negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. So x is equal to 6 plus or minus the square root of 36 minus, and let's see, 9 times 16 is 144. All of that over, and then the 2a was what? That's 2 times 4, that's 8. So this is 6 plus or minus square root of negative 108 over 8. Now at this point, square root of negative 108 is what kind of number? That is a complex number. I was tasked with finding all real solutions. So I know that at this point, I can pretty much stop. This is going to be a complex number. So that means that x equal negative 3/2, that is my only real solution. Now, one thing I'll go ahead and tell you, and you can just know this, is that anytime you factor the sum of cubes, this term right here, this quadratic, it will always have complex solutions. So there are no real solutions to that. So if you ever get to sum of cubes or difference of cubes, and you're setting it equal to 0, know that this quadratic term only has complex solutions. So your only real solutions will come from the linear term that you see here. Let's look at the next example. This one, so my key is to set it equal to 0. So 5b cubed plus 12b plus 15b plus 36 equal 0. The only method I have for something that has 4 terms and I'm factoring it is factor by grouping. So the first 2 terms have a b in common, and I'm left with 5b squared plus 12. Bring down this sign plus, and now I can factor a 3, and I get 5b. Did I do this right? Oh, sorry. This 15 was a b squared. Okay, so typo on my part. So now I've got the same thing in parentheses, factor by grouping. This is b plus 3 times 5b squared plus 12 equals 0. Set each factor equal to 0. b plus 3 equals 0 means that b is equal to negative 3. 5b squared plus 12 equals 0 means that 5b squared equal negative 12, b squared equal negative 12/5. At this point, I know that this is complex because when I take the square root of a negative number, so the solution of this is b is equal to plus or minus I square root of 12/5. This is complex, so this is my only solution because I was told to find all real solutions. So that is my only solution, b equal negative 3. So the other solutions are complex in this particular case. So if I look at this one, again, my strategy is to get all the terms on one side. So let's just say negative 27 g cubed plus 15 g squared plus 6g to the 4th equals 0. It looks like I can factor out a 3g squared, and I'm left with negative 3g plus 5 plus 2g squared. All of that equals 0. So let's rewrite it like a quadratic where it's in the right order. So this is 3g squared. So 2g squared minus 3g plus 5 equals 0. Now my question is, can I factor what is inside the parentheses? If it factors, there are 2 numbers that multiply to give you a 10 and add to give you a negative 3. So the numbers that multiply to 10 are 1 and 10, 2 and 5. There's no way to get a negative 3 out of that. You might be tempted to say, well, I could have a negative 2 here, but those would multiply to give you negative 10, not 10. So that doesn't work. So this cannot be factored. So now I'm going to need to use quadratic formula. So this is ax squared plus bx plus c equals 0. So solving for g, so g is equal to the negative of b, that's 3, plus or minus the square root of b squared, so that's negative 3 squared, minus 4 times a times c, all of that over 2a. So this is 3 plus or minus 9, and that is okay, hold on, I gotta back up. I just realized that I made a mistake here in the factoring step. So things were not looking right, so let me go back and we'll take care of that. So if I'm factoring this, factor out then factor out the 3g squared. So if I factor out a 3g squared, then I'm left with, here was my mistake, negative 9g, because 3 times negative 9 is 27, plus 5 plus 2g squared equals 0. And so this is 3g squared, and then I've got 2g squared minus 9g plus 5 equals 0. Looking at that quadratic, are there two numbers that multiply to give you 10 and add to give you negative 9? There are not numbers that do that. So this one cannot be factored. So I'll go to quadratic formula. So g is equal to negative of b, that's 9 plus or minus the square root of negative 9 squared minus 4ac, which is 5, all of that over 2 times 2. So this is 9 plus or minus 81 minus 40, all of that over 4. This is 9 plus or minus the square root of 41 over 4. So what are all my solutions? If I set this equal to 0, 3g squared, then I'm going to get g is equal to 0. G is also equal to 9 plus or minus the square root of 41 over 4. So there are three solutions: 0, 9 plus square root of 41 over 4, and 9 minus square root of 41 over 4. Those are the three solutions to that equation. Next equation, 4 things. The only method I have is grouping. So let's see if we can factor this and this. Okay, if I factor those, the first things have an x cubed in common, and I'm left with x squared minus 1. Bring down the sign that you see there, that negative sign, and it looks like I factor out an 8. And I do that, and I get x squared minus 1 equals 0. Now I get x cubed minus 8 times x squared minus 1 equals 0. You should have bells going off in your head, because the first term, that's difference of squares. The first term is difference of cubes. Second term is difference of squares. So to factor the first term, that is x minus 2. I'm just using my formula for factoring the difference of squares. So that's the first term factored. The next one is just x minus 1, x plus 1. So all of that is equal to 0. When I set these factors equal to 0, those are my real solutions. You can try it, but you should be remembering, anytime you factor the difference of cubes, that quadratic will not have real solutions. You can try it. It's going to be complex if you didn't remember it. But my only solutions here are x equal to 1 and negative 1. Then let's look at the last one. This guy, 2x to the 5th plus 24x minus 14x cubed equals 0. What can I factor out? It looks like I can factor out a 2x, and I'm left with x to the 4th plus 12 minus 7x squared equals 0. And if I rewrite this, 2x, x to the 4th minus 7x squared plus 12 equals 0. What I see in parentheses is not a quadratic, but it is quadratic form. So it factors just like a quadratic if I can find two numbers that multiply to 12 and add to -7. It looks like a -3 and a -4 will do the magic there. Those numbers multiply to 12 and add to -7. So I can write this as 2x, and then I'm going to write this as x to the 4th minus 3x minus 4x plus 12 equals 0. And now I need to factor by grouping again. So look at those terms and these terms. So I'm going to have 2x. And then in the parentheses, I'm going to factor out an x, and I get x cubed. Sorry, I made another mistake. This is x squared. So I'm going to factor out an x squared, and that leaves me with, so sorry about that. It's late in the day. I'm making several mistakes here. This 2x is already there. So now, when I look at this grouping, I'm factoring out an x squared, and I'm left with x squared minus 3, and then minus, and here I'm going to factor out a 4, and I'm left with x squared minus 3. So all of that equals 0. So now I've got 2x times x squared minus 4 times x squared minus 3 equals 0. And now let me just move over to the right so I get a little bit of extra space. Set each of those equal to 0. 2x equals 0, that means that x is equal to 0. That's one of my solutions. And then if I look at x squared minus 4, that could be factored further. So the further factorization is just going to be x minus 2, x plus 2, x squared minus 3 equals 0. So I get that x minus 2 equals 0 means that x equals 2. That is a solution. X plus 2 equals 0 means that x equals -2. That is another solution. And I can't factor x squared minus 3. That's not factorable as a perfect square with rational numbers. So when I set that equal to 0, I get x squared is equal to 3. Take the square root of both sides. You get x equal plus or minus square root of 3. So x is equal to square root of 3, and x is equal to negative square root of 3. So there are 5 solutions to this particular problem. Okay? So again, that is a lot, but you've got to keep straight everything we've talked about in terms of factoring, greatest common factor, factor of quadratics, quadratic form, difference of squares, difference of cubes, sum of cubes, all of those. So it's a lot to keep in your head in terms of the tools you have for factoring. Okay, thanks.